Hi everyone, welcome to my YouTube channel, Zenith GATE Mechanical.
So the question number 7 is the glass and the ceramic material which are machined by, there are the four options. One is the transferred arc plasma machining. The option B is ECM, and the option C is USM, that is ultrasonic machining, and the option D is electric discharge machining process. So you have to identify out of all these four options, which machining process is most suitable for machining of glass and the ceramic. Okay, so first of all these options which are given in this particular problem, these all machining processes are nothing but the non-traditional machining process. That means unconventional machining process. The glass and ceramic material is basically, it is a hard and brittle material. So you cannot machine with the help of the conventional approach. That's why you use the non-traditional machining or unconventional machining approach. So the glass and ceramic, these material, glass and ceramic are machined by ultrasonic machining method. So it is a non-traditional process that uses a high frequency, which is approximately 20 kilohertz, high frequency vibration to remove the material from hard and brittle material like glass and the ceramic. Okay, so for this particular question, the correct answer is option C, which is ultrasonic machining. Okay, but I want to give some insight of this ultrasonic machining. So what is actually happening in ultrasonic machining? This is ultrasonic oscillator, which basically convert this low current frequency to the high frequency current. And there is a transducer which convert this electrical signals into the mechanical vibration. So at the end of this horn, there will be a tool. Okay, so this tool is vibrating with certain frequency, which is nothing but approximately 20 kilohertz. And the gap between the tool and the workpiece, you are passing the abrasive slurry, which contains some abrasive particle like Al2O3. Okay, so once this tool is vibrating, so what is happening? This tool is creating a impact on this workpiece with the help of these abrasive particles. Okay, so there are small abrasive particles are there, and these abrasive particle, when they are coming in contact with this workpiece, so it will erode this workpiece surface. Because of that, there will be a material removal process takes place. Okay, so the ultrasonic machining process basically uses a tool which is vibrating with certain frequency, which is nothing but 20 kilohertz, and in between you are flowing some abrasive slurry. So these abrasive slurry having some abrasive particle, and then they are coming in contact with the workpiece and it will erode. So for this question, the glass and ceramic material, you can machine with the help of ultrasonic machining. So the option C is the correct answer. Option C is the correct answer. Okay. So let's move to the next question. This question is from the welding. So what is the question? The welding process commonly used for fabricating tailor welded blank of dissimilar thickness for automotive application is, that means four options are given. So gas welding, friction welding, arc welding, and the laser welding. So you have to identify for fabricating tailor welded blank, which welding process is suitable. Okay, so first of all, you have to understood what is tailor welded blanks. So tailor welded blank are the blanks? They are made from two or more sheet of metal with different thickness, with different thickness, and they are welded, and they will form a single blank. They will form a single blank. Okay. So two or more sheets of metal you can take with the different thickness, and they are welded and they will form a single blank, that is called as a tailor welded blank. Which welding process is suitable? So the correct answer for this question is laser welding. Laser welding is used for this. Okay, so the laser welding is used for this particular purpose. Why? Because it provides a narrow heat affected zone, narrow heat affected zone, and also it reduces the or minimizes the distortion. Minimizes the distortion. Okay, so the correct answer for this particular question is option D. So option D is the correct answer. Let's move to the next question. This question is from the material science, that is from heat treatment. Among the following, the surface hardening process, in which process the steel is heated to the lowest temperature? Okay, so all these four processes are case hardening process only. What do you mean by case hardening process? Case hardening process means, so if you want to make the surface hard and the core should be soft, so that for that you will do the case hardening process. For example, in case of nitriding, you will use the nitrogen to diffuse into the surface of the steel, and that nitrogen is coming from the ammonia gas. Similarly, for the carburizing, so in case of carburizing, you will use the carbon to make the harden the surface. That means in all these processes, you are making the surface hard, but the core should be soft. But in all these processes, in which one the temperature will be less, you have to identify. Okay. So what is case hardening first of all? Case hardening, or it is also known as a surface hardening. Case hardening, that means the surface is hard and the core is soft. And the core is soft. Okay. So in case of nitriding, so nitriding is a surface hardening process. Surface hardening process in which the steel is heated to a temperature relatively low temperature, so approximately from 500 degrees centigrade to 600 degrees centigrade, in a nitrogen rich atmosphere. Okay, so that means the nitrogen is basically diffused on the surface of steel to make the surface harden. Okay, so from where this nitrogen is coming? From the ammonia gas. Okay, now if I will see the other options, what will be the temperature? What will be the temperature for them? So if I will talk about cyaniding, the temperature is around 760 to 870 degrees centigrade. For carbonitriding, the temperature is around 800 to 900 degrees centigrade, and for carburizing, the temperature in the range of 850 to 950 degree centigrade. Okay, so if you see all these options, so the minimum temperature you will achieve in case of nitriding only 500 to 600 degree centigrade. So the correct answer for this question is option A, which is nothing but nitriding. Option A, which is nothing but nitriding. Thank you so much.